Dr. Jeremy Hoffman, principal at Hoffman Science Associates, has over a decade of experience in the Science Center and public engagement field. Dr. Hoffman connects audiences to their changing planet through participatory environmental research and interactive, hands-on, and immersive experiences. His research and work has been featured in the New York Times, National Geographic, and the Washington Post. Dr. Hoffman was selected as the chapter lead for the Southeast region in the 5th National Climate Assessment, a fellow of the American Association for the Advancement of Science in 2021, one of the Blue Loop 50 Museum Influencers of 2022, and was recognized as an American Alliance of Museums Rising Star in 2023. Welcome, Jeremy. We're so happy to have you.
Thank you so much, Emily, and good afternoon, everyone. I'm seeing so many cool places represented in the chat. I'm reporting to you live from 70-degree Fahrenheit, Richmond, Virginia, where I have lived for the last few years. And so my background is in climate science. And as Emily mentioned, I've just recently helped bring over the finish line the 5th National Climate Assessment. If you're interested, I'll share a little bit about that later in the talk. But the National Climate Assessment has both regional chapters, which would be related to where you live, as well as sectoral chapters, including one on biodiversity, agriculture, water. It's a very varied array of different sources of climate information that you can use. And really what I'm here to do is inspire you to think about communicating climate change in perhaps a different way than you're used to, specific to plants and animals. And this is through phenology, or the life cycle events in plants and animals, and how that can help arboreta and public gardens or botanical gardens participate in the climate change conversation in a way that is really in your lane and allows you to lean into some really innovative stuff that's going on in the study of phenology around the country. So right away, I always love to do this. Start my talks off, because you don't know who I am. Who is this guy? I come into this work very much from an outdoors enthusiast perspective. Beyond the flawless, wardrobe decisions that you see in these photos. The important thing is the fish, right? So my dad raised me to be a fisherman, taught me how to take measurements of using a rain gauge to understand how deep the water was going to be, or potentially how turbid the water was going to be, whether it was really, really hot compared to the average. So from a very young age, I was taking advantage of the scientific tools to understand the world around me. And throughout my life, there's been this really interesting unfolding story going on at the same time. They're starting in about 2016, when I was a graduate student at the Oregon State University in Corvallis, Oregon. Friends of mine from that area in northwestern Wisconsin, where we would go fishing during the summers, started sending me newspaper clippings from their local newspapers showing that, there's a real world walleye decline happening. And if you don't know anything about walleye, one, they are delicious to eat. They are one of the most popular kind of like ecotourism, like edible fish, game fish in these lakes. They're not the largest, and they're not the most exciting to get on your line, but they are one of the most kind of like sought after for their taste and flavor. And so what you can see about these newspaper clippings too, the Bayfield County Journal or Sawyer County, is just how important that lake and outdoors identity is to their local economies. You can see this big musky head. This is Sawyer County, has the world. I think it's the world record sized muskie was caught near Sawyer County, Wisconsin. And then this sailboat in Bayfield. The outdoors are part of how small towns in Wisconsin orient themselves and into ecotourism. And so what's interesting about this is that as it was a mystery what was happening to these walleye, the DNR started looking at the long-term records from lakes throughout the region and showed that over the last 35 years or so, there had been a very steady decline in the number of walleye, or walleye reproduction, in the number of young walleye per mile of coastline. Here in the green line, you can see it decreasing over time. And then on the right side, or in the red line, you see the relative abundance of largemouth bass in relation to the young walleye. Now, this means basically that there were relatively more bass and fewer walleye in the lakes. But what this is saying is that there's something about the environment that is more conducive to bass and less conducive to walleye over time. A few years later, scientists were looking at all of the different ways that lakes can change, from the leaf litter that makes it into it, the number of sunlight hours, the dirtiness, the turbidity. And the one thing that changed monotonically along with these percentages of these different fish was the temperature of those lakes. And so not only this paper that came out, but several others have confirmed it. Now you can find it on the Minnesota or the Wisconsin State Climate website. That one huge discussion about climate change and walleye is that the warming up of these lakes is what's driving these species distributions to flip from being relatively more likely to catch the delicious walleye to being more likely to catch the not so delicious largemouth bass. Now, this little star in the northwestern part of the state here is where my family would go fishing near Hayward in kind of an hour and a half south of Duluth. Now, why do I bring this up? It's because this points to this kind of regional and shift in how the natural world is organizing itself. And so the part of the reason why these lakes are warming up is because at the end of the winter, the lakes are losing their ice earlier. So some of you that are from the upper Midwest, you're entering the winter season. You know what it's like to live out a Midwestern winter. It's cold. It's dark. What's one thing you look forward to? The thaw. So we've been actually tracking the date of the ice thaw on these different lakes around the upper Midwest for many, many years, and have shown that places like Lake Superior, the ice thaw date is almost a month earlier than it was in the past. This means that those lakes have much more time to absorb the sun's energy throughout the year, contributing to their long-term warming. Now, it's not only happening in the Midwest. Of course, we know it is happening basically across any of the lakes that we have long-term ice thaw dates on them. So this is not just restricted to the Midwest. This is happening seemingly everywhere all at once. And it's not just happening to lakes that freeze. We see that stream temperatures across the country are increasing. The environment itself is shifting due to this long-term change in our climate. Now, and we just saw, Emily mentioned it, that the plant hardiness zones, which are reliant on their definition through the minimum temperatures that are expected in a place, have just shifted. And so our climate zones are moving northward along with those temperatures. And so I wanted to share that with you because I come to this conversation around climate change from a very personal side. I want my niece, who's 2 years old, to experience what it is to catch a walleye and make her walleye and eggs like my dad used to. And so I come to this from very much in my identity is linked to the natural world. And I like to inspire people that might have seen themselves not as being a climate actor to being engaged with and contributing to the climate conversation in this country. And so this talk I like to call the birds and the bees. We're going to go through a quick little definition of what exactly climate is in relation to weather, and go through a definition of human-caused climate change. We're going to go through this phenology side of things. And I'll end with some strategies that you can take into your institution, or maybe start to think about how a campaign around climate change engagement might look at your location. And so what exactly is climate? The climate we tend to think of as in the textbook definition is the 30-year average of weather. And this means weather at any one time is what's happening outside. Today, 70 degrees Fahrenheit. It's not a cloud in the sky, nice and warm, a 5 mile per hour breeze out of the southwest. That's the weather today. But the long-term average, the climate, would relate to like, what is the expectation of a day like today or yesterday in this case, 60 degrees Fahrenheit at 3:40 p.m. yesterday. And what we can kind of think about actually is that on average, we think of that day being about 70 degrees Fahrenheit or so. So when I talk about the weather, what you can think of in a kind of analogous sense is like an at bat or some sort of event happening that has a bunch of different potential outcomes. This batter could get a home run. They could strike out. They could walk. Think of anybody taking a free throw or kicking a field goal. Any of those things that are dependent on a big system working together to reach an outcome. You can relate this to any sport you like. You can also think of it as like a playlist and the song that's playing, or your mood versus your personality. But I like to use this sports one just in case. So this Wednesday yesterday was a high of 60 degrees. But in order to understand the likelihood of that, we look at the long-term average. This is like looking at that same player's baseball card and seeing their batting average, which is the long-term expectation of how often or not they get a hit. Now, this is Mickey Mantle's baseball card, and you can see his long-term batting average was 0.3. That means 1/3 of the time he was getting a hit. Now, in this case, most of the time on a mid-November afternoon, we've got averages hovering around the 60s. Now, today is 70 degrees Fahrenheit, 10 degrees way over average. So when we're thinking about the weather and the climate, we have to really think about what our expectation is, which is the climate, and then the weather, which is what's actually happening outside. Now, we can also think about this from the perspective of the clothes that you're wearing versus the clothes that you have in your wardrobe. It's going to be very different, someone living in Miami and what the clothes they have in their wardrobe versus someone that's living in Minneapolis and what they have in their wardrobe. Now, now that we've had a definition of kind of what climate is, what does this mean, and what does this say about what human-caused climate change is? And in order to answer that question, we have to kind of go back a couple hundred years and go through a little bit of the history of climate science in the process. First, really some of the most foundational work on how the climate system works was done by Joseph Baptiste Fourier, a French mathematician in 1824. He was the first one to surmise that the Earth should be way colder than it is. The surface temperature of the Earth should be hovering around freezing. But there's something special about the atmosphere that must be allowing the sun's energy to come in, but then trapping some of the heat at the surface. Now, he deduced mathematically that the greenhouse gas effect exists, but he didn't call it the greenhouse gas effect. And he didn't know what it was in the atmosphere that was doing that. It took another 30 or so years until John Tyndall in 1859 actually isolated some of the gases that were in the atmosphere and then basically ran heat through them to see how they reacted. And he was the first one to really publish observations that things like carbon dioxide, water vapor, and so on are really potent heat-trapping gases. Now, it actually turns out that there was a woman several years earlier named Eunice Foote who did these experiments herself and reached similar conclusions. But because she was a woman in the mid-1850s, she was unable and actually restricted from sharing her findings at major scientific conferences. So although Tyndall is generally seen and acknowledged as the one that contributed that science, a woman did it a few years earlier. Now, fast forward a few 40 or 50 more years, we get Svante Arrhenius, who was a Swedish mathematician and engineer who deduced how much the Earth's atmosphere would warm up by doubling the amount of CO2 that's present in the air. Now, this is really interesting because, one, he didn't have the sophisticated climate models that we have in the present. He did all of that math by hand, and he came up with an answer that really isn't that far off, which is really, really impressive. You know, to have the prescience to say, I'm seeing all of this industrialization happening around. We're using coal mostly to burn, to power this energy and industrial revolution. And that's adding CO2 to the atmosphere. I wonder what that's going to do. And then calculating a value for how much the Earth would warm up if you doubled the amount of CO2 in the atmosphere, and being not that far off, really, really impressive. Now, another 40 years in the future, Guy Stewart Callender, an engineer, he was the first one to claim scientifically that he could detect the Earth's surface temperature changing alongside increases to CO2. So as early as 1938, the ideas around the human contribution to the greenhouse gas effect and then its corresponding impact on the surface temperature of the Earth had been largely already figured out. Since 1938, it's basically been just refining the story more and more, never changing the main characters. So as we move forward with this, really it comes down to there's a natural greenhouse gas effect that keeps our planet habitable, but the people who have figured out how to burn coal, oil, and gas to power our world in the past has contributed to an intensified greenhouse gas effect. We can see this from space, and we can see it in a lot of different other planetary systems. In a sense, CO2, more CO2 in the atmosphere is just adding more wool blankets to the Earth. Everyone knows what it's like to have an uncomfortable sleep because you're too warm. Now, it's not perfect. If any of you are physicists, this is definitely not exactly how it works, but nonetheless, it's a useful metaphor. Now, you might be wondering, and I like to quickly go through this, how do we know that CO2 has actually been changing in the atmosphere? In order to do that, we have to go to San Diego, to La Jolla, and go and see this guy, Mr. Keeling, Dr. Keeling, who, like his father before him, has been collecting air coming off of the ocean, the Pacific Ocean, for many, many years, and analyzing that air for its carbon dioxide content. And since 1958, when his father started taking these measurements, we've actually seen a slow but accelerating increase in the amount of CO2 in the atmosphere. So somewhere around 310, 315 parts per million in the air back when this started, all the way up now to being closer to 420 parts per million. You can see how much it's gone up since the last time I made this slide in 2018. Now, you might see something really interesting here. There seems to be some sort of Z pattern or like sawtooth pattern. What's going on there? Well, as plant people, you're probably aware that as plants grow, they absorb CO2, or they kind of breathe in CO2 through photosynthesis. And as they decompose, they actually put that CO2 back out into the air through respiration. So sugar takes it, and respiration breaks it, is basically the way that it goes. So that zigzag pattern is actually the Earth breathing. Most of the Earth's land mass, and then therefore the biomass, is in the northern hemisphere. So CO2 goes down during the spring and into the summer, and then CO2 rises as the plants in the northern hemisphere decay into the fall. So this little zigzag is actually the Earth breathing in and out. But one good question to ask is like, well, how do we know that this amount of CO2 in the atmosphere is any different than it's been in the past? 310 to 420, who cares? In order to do that, we have to go to the coldest places in the world and take basically like hole punches of the ice sheets, and then take a look at their pancake layers of individual summer, winter cycles, and see how on this one slice of the ice core here, you can see almost like constellations of air bubbles. Those air bubbles are just like the flasks of air that the folks in San Diego are using to measure the Earth's atmosphere, but locked in the ice that is miles beneath the surface of the Antarctic ice sheet. It's the most amazing physical discovery that you can reconstruct the Earth's paleohistory from environmental archives like ice cores, tree rings, and sediment cores. So what does that data tell us? Well, for one, if we go back to about the Declaration of Independence, we can see that at the founding of our country, CO2 was somewhere around 270, 275 parts per million. And through the beginning of the Industrial Revolution, that started to go up. And starting at about 1950 or 1960, there's been a steady acceleration. So even with relation to when our country was founded, we're several, over 100 and 125 parts per million higher than the CO2 in the atmosphere was only a few centuries ago. Now, looking back even further, this is roughly where we are today at the star. Here's where the Declaration of Independence happened. If we look at the last 10,000 years, we can see that prior to the 1800s, CO2 didn't change really much at all in comparison to the last 100 years. In fact, if we look at where humans started contributing agriculture, which actually shifted some land use and started to contribute CO2 to the atmosphere, CO2 never climbed above about 275 parts per million. Now, the real big question is just how weird is this with respect to all we know from ice cores? In order to do that, we can look at the deepest, oldest ice core, which is 800,000 years of Earth's history in one ice core. Just absolutely beautiful record of Earth's history here. This is really the heartbeat of the climate system. We see times where CO2 is relatively high, like today, somewhere around 270, as much as 290 parts per million at times, and as low as 170, 180 parts per million. It turns out when the CO2 was really, really low, that was the ice ages. All of these low points were periods of large continental ice sheets. You might have heard of the Ice Age. Well, there's been multiple ice ages in the past. The most recent one ended about 20,000 years ago, and that's the one that we typically have the most evidence for at the Earth's surface. Where I grew up in Wisconsin, in Iowa, in Minnesota, all those places you can find evidence of the glaciers that were there just a few tens of thousands of years prior. Now, what you can see is that in the last 800,000 years, there's been nothing anywhere close to the amount of CO2 that's in the atmosphere today, and the rate at which it has changed has been largely outpaced at any other time in Earth's history that was able to do it naturally. Now, I can't go into everything about paleoclimate. I love talking about paleoclimate. If you have paleoclimate questions, feel free to throw them in the chat, because we're going to start leaving the discussion of paleoclimate here in a second. But just to give you one more perspective, Homo sapiens, our species, evolved somewhere around 300 to 400,000 years ago. And so we've lived through times where the climate has shifted dramatically over many thousands and thousands of years. We've never lived at a time period that is changing as rapidly as it is in the present. And so humans have profoundly altered the natural heat trapping gas ability, or the natural heat trapping ability of our atmosphere in this absolutely geologically rapid amount of time. And this has completely changed our planetary system, leading to several changes that are observable over a short amount of time in various places around the world. And so one of them being global temperatures. Increase the ability of our atmosphere to trap heat. What happens? Heat continues to get more frequent, more intense, and the long-term shift towards a warmer climate is made no more apparent, I think, by any other data set than the warming stripes. If you want to go and get your own warming stripes, like I've done here for Washington, D.C., you can go to showyourstripes.info, and you can actually get your own city's climate warming stripes. Basically, their color corresponds to how low or high in relation to the long-term average of the 20th century climate the last few years and any individual year has been. Mostly, without fail, the last 20 or so years tend to be the warmest on record. Globally, the last 3 decades have been the warmest on record. Locally, here in Virginia, the last 10 years have been the warmest on record. And 2023 is by far going to be the warmest year on record as well. So this is every single year can bounce a little bit around that long-term trend, but without question, global climate change is accelerating and we are warming up. Now, this means that several things are happening all at once. We can talk about all of these different indicators, and from things like ice sheets shrinking in size, and then their water going into the ocean, raising sea levels. We can talk about, the humidity in the atmosphere increasing because a warmer atmosphere is a bigger sponge, so it holds more water in it. We can talk about all these different systems, but today we're going to be talking really about the change in our seasons and how that is shifting species, plants, and animals in our landscapes. And so this is where most of the rest of the talk is going to go. We know that human-caused climate change is happening, but how is that affecting things like local birds, bees, flowers, trees, and other things? First and foremost, let's look at the evidence for those warming seasons. A couple papers that came out in the recent past by my colleague Mike Allen, who's at Towson University outside of Baltimore, Maryland, has been looking at and evaluating the onset date and length and end dates of these different seasonal indicators. So basically, you can think of when a individual place sees a kind of seasonal shift, like you have warm temperatures in the summer, cold temperatures in the winter, you can start to think about thresholds that indicate that we've switched from one season to another. We tend to think of that being related to like daylight savings time. But by looking at the actual statistics of when you have a seasonal shift in the expected temperatures of a particular time of the year, looking through that, we see that places like springs and summers are moving earlier into the year, and autumn and winter onsets are moving later into the year, almost without exception. By several days per decade. So for every 10 years, we see about, a day to 3 days earlier springs and summer conditions. Meanwhile, we're seeing the arrival of autumn and winter happening later and later into the year. So it means that the summertime, really the warm season, is fattening out into the edges of our year, and the winters are shrinking and shrinking. This has huge, profound effects on things like the types of plants that can survive in individual places. This is what eventually drives the plant hardiness zones to change in a particular place. As an interesting side note, Richmond, Virginia, and Atlanta had the largest detected changes in the onset of these different seasonal changes. And so I live in Richmond, Virginia. A little weird claim to fame is that we have the most rapidly shifting seasons in the country. And you might be saying like, okay, well, this is actually okay. More warm time. Yay. I love the Postal Service. They say we can swim any day in November. And so you might be thinking that this is this might actually be a good thing. Unfortunately, the longer that we have these warm temperatures, the more there is the opportunity for vector-borne diseases to spread to new places that they've never experienced before. So in almost everywhere around the country, mosquitoes are able to survive for a longer time of the year, and new species of mosquitoes are arriving in places that they've never been before. This means that people are this makes people more susceptible to the kinds of diseases that they carry, like chikungunya, West Nile virus, dengue. And in the northern part of the country, ticks are able to survive and overwinter more successfully. So ticks carry a variety of different types of diseases, including Lyme and Rocky Mountain spotted fever. Now, we also see this ticks increasing in their ranges in the Southwest and Southeast. This is more to do with land use patterns. As we as we fractionate our native forest lands, that creates more forest edges, and so that actually enhances the mice and deer habitat that the ticks thrive on, and more people move into those places. And so we have more humans being exposed to ticks, not for a climatological reason, but for a land use reason in the Southeast and the Southwest. So that's just an interesting aside, that even though it might seem like that we have a more enjoyable seasonal arrangement here, that actually it turns out that the risks associated with vector-borne diseases are increasing. And this is from the new National Climate Assessment that was published on Tuesday. Go to nca2023.globalchange.gov to take a look at all of the different chapters that are available. Now, I want to tell another story about these warming temperatures. Here in Virginia, we don't have any national standard pollen assessment locations. So Becky Colley, or also effectively or lovingly known as the Pollen Lady here in Richmond, Virginia, has been climbing up to the roof of the Allergy Partners Richmond location at the Henrico Doctors Hospital just outside of the city of Richmond since 1988. And what she does is she uses this little machine to collect pollen and mold spore samples from the atmosphere. And she's been writing them down in spiral bound notebooks over the last 35 years, and found some really spectacular things with her data. We digitized all of it. And by looking at the change in the pollen counts through time, we were able to show that, here's what some of the data look like for a particular season. So this is from 2017. So you can see in February, there's a little early spring. This tends to be like juniper and cedar gets going early and that kind of thing. But then there is a peak tree pollen date. So there's this peak here in kind of like early April. This is the day when your car is covered in like yellow slime or yellow dust. This is kind of what that peak tree pollen date is. And so you can see the date here is April 12th, 2017. And that corresponds to a peak tree pollen count, 4,000 grains per cubic meter of air. This is a day that's extremely sneezy. Even if you aren't clinically allergic to the pollen that's in the air, there's just so much of it that your tear ducts react and you start to have the watery eyes and you sneeze just because there's so much of it in the air. So when we look at like, what does her data say about Richmond, but it over the last 35 years, it turns out the day of the peak tree pollen day, the worst day of the year, has moved backwards in time by about 7 days. It's actually extended a little bit more. This was data from 2017, as I said. Now we have another 5 years of data. This has moved back only another day and a half. So now we're over a week earlier on average, and the amount of pollen in the air has gotten more intense. This is both related to the seasonal temperature changes as well as CO2 in the atmosphere. It turns out CO2 is plant food, but it's not good if that plant food is feeding allergenic producing pollen organisms. So other things like ragweed and poison ivy and things like that thrive in higher CO2 conditions. And by having a longer growing season, that means that not only are they able to produce pollen for a longer amount of time, they're producing more of it. Why does this matter? Kids breathe more volume air per unit body mass than adults do. This is a climate impact that disproportionately affects our young people and is directly related to the surge in allergenic pollen or allergenic rhinitis cases in young people. This is absolutely related to a changing climate. In fact, many papers have found this exact same thing happening all over the country, pretty much without fail. So when we think about what this means is that we have a sneezier climate thanks to climate change. And this has a direct health impact to us. So these longer, more enjoyable warm seasons come with a cost, a very severe health cost. Now, also, we can see this not only in those flowers that are producing allergenic pollen, but we can see this in basically every national park in a variety of different flower species. So this is from a NASA publication in 2016. That's showing that the first bloom date is moving earlier into the season by, in a lot of places, 10 to 15 days earlier than it did earlier over the course of the century. So it's 2 weeks earlier. Now, this is a big deal. I saw one of these questions in here about Boston. Even though the individual weather station might not be significant at 95% confidence, the plants are showing that there's actually no exception to this all the way up into the Northeast. Some of the most dramatic changes to our first flowering dates and spring arriving earlier is concentrated in the Northeast. So even though the weather station might not show it, the plants are showing it themselves. So throughout the country, 75% of the U.S. national parks are showing the same pattern of an earlier bloom date. Now, what does this mean realistically for things that are really, really important? So in the case of Washington, D.C., the peak bloom of the cherry blossoms is a hugely important ecotourism event to the D.C. Area. Interestingly, the planting of the cherry blossoms in the Tidal Basin was the first public project undertaken by a first lady in the U.S. history. It was Helen Taft and the Viscountess Iwachinda from Japan that worked together on planting all of the first cherry trees around the Tidal Basin. And anyway, the USGS has been recording their peak bloom date since 1921. And up on this chart is going to mean earlier. So my charts typically go down, meaning earlier, but in this case, up means earlier. And so over time over the last century or so, the peak bloom date has moved earlier into the year by about a week. And this has meant sometimes where the Cherry Blossom Festival, which is indicated by the pink circle here, is well outside of when the actual peak bloom is. And interestingly, they've had to fatten out. You can kind of see how they changed the National Cherry Blossom Festival to be happening from April 10th to March 21st, or March 21st to April 10th. It's like 3 weeks long now because they have to make up for this very unpredictable and earlier appearing peak bloom possibility. Now, this is also not just happening in Washington, D.C. Actually, monks in Kyoto, Japan, have been writing about their sakura, their cherry blossom trees in Kyoto since a couple hundred years ago. And so down on this chart is going to be earlier, like I like to represent it. And what they looked at was basically the monks in recording these peak bloom dates. The peak bloom of the Kyoto cherry blossoms has also moved earlier into the year by about 2 to 3 weeks. And so this is undoubtedly relevant to the urban heat island effect, which increases minimum temperatures. But this is right in line with the predictions of global climate models that predict that an earlier flowering date corresponds to not only shifting minimum temperatures, but maximum and the arrival of springtime averages. Now, why does this matter? It turns out that earlier bloom dates leave these plants open to really high vulnerability from a weather event like a cold snap. And so in this case, you can imagine two worlds, one where the winter is very reliable. It's happening until the trees themselves are nice and the buds are all clear, and we get the really nice trees when we have an average temperature that's much colder. And so the late season frost has very little effect on the plants themselves. But in a warming world, we have this earlier arrival of snow-free conditions and so on. And so we actually have the plants producing very robust needles earlier in the year. They get slammed by something like a late season frost, and then they're very significantly damaged. It turns out that this is the case for things like fruits. Georgia peaches are very vulnerable to late season freezes like this. Apples, other sorts of really temperature sensitive crops that then affect things like our agricultural communities. Now, one that you may or may not participate in is wine. It turns out that the wine industry in France has been tracking their harvest date. And over time, while there's a lot of interannual and decadal variability here, the harvest date is much earlier than in the past, and the earliest among all of the records that go back into the 1800s. This ultimately has an effect on the places that have established wine industries. This has an effect on where the wine industry can exist in the United States. It's actually been a bit of a boon for the wine industry in the Northeast, whereas in the Southeast, it has been a bit of an issue. So by 2050, might we be entering a future without wine? You know, there's a lot of different food-related stories we can tell, things like pumpkins. We could talk about chocolate. We could talk about coffee. But I find that sometimes adult audiences really react well to stories about wine. In fact, let's talk really quickly about a spooky story about pumpkins. We're coming up on the Thanksgiving holiday. If you like pumpkin pie, most, if not all, of your pumpkins are grown in South Central Illinois. The Libby Pumpkins company is there, and heavy late summer rains in 2015 basically ruined the crop that year, and so there was a shortage of pumpkin. Like pumpkin puree. And so the Nestle USA spokesperson, in reaction to this shortage, just said, maybe that means you'll have one slice of pumpkin pie instead of two. It's just like such a weird way to say, you know, like there's this, you know, a few different things all happening in that one statement. But really, the future expectation is that this part of the country will see more unpredictable shifts in precipitation. That has downstream, quite literally, impacts on their agricultural communities, and therefore the people that enjoy things like pumpkin pie. So this Thanksgiving, tell the spooky story about how late season rains in the Midwest related to a shortage of pumpkins in that region. So this little outline here in the yellow is an area that might see much more wettest 5-day periods by mid-century. And this was from the last National Climate Assessment. Let's quickly reflect on things like animals. We haven't really talked at all about animals. This is a study from the Audubon Society showing that the average distance of different birds, like the latitudinal center of bird abundances, have moved further northwards by about 30 to 40 miles over time. This is reflecting a more habitable climate for them as global warming advances and regional warming advances. Populations are able to settle further north than they were in the past. Now, we also see this happening and potentially happening further into the future. This is supposed to show a shift over time. Unfortunately, because of animations, it maybe won't show. Yes, it won't exactly show what I'm hoping for. But here, you can actually go to the Audubon Society website and see how individual bird species distributions are supposed to shift into the future, with the loon making much more of a winter range in the northern part of our country, and their summer range shifting much more further north, and that kind of center of their abundance moving. Now, one that's really important for the local stories here in Virginia is the wild turkey, which I know if you're a Virginia Tech fan, Hokie Bird isn't really a turkey, but come on, that's a turkey. Anyway, turkeys are actually expected to shift almost outside of where their native ranges are in the Southeast, and that has a big impact on outdoors people that like to go hunting for their own types of birds that they want to eat for Thanksgiving. And really beautiful species like the purple finch might not be anywhere in the United States by the mid-century. And so if you want to start telling these stories yourself at your arboretums, at your botanical gardens, I really strongly encourage you to go and read the ecosystems chapter from the 5th National Climate Assessment. It has exactly the kinds of things that you're looking for, talking about invasives, talking about trees, talking about ecosystem services, and all of these things need to be part of your parlance. Rely on the National Climate Assessment. Over 700 authors contributed to the state of this science. Real quickly, not only bees, but basically every system that we have evidence for is showing that there's either been a latitudinal, elevational shift northwards or upwards as well as either advancement of things like plant flowering or a delay in the onset of things like hibernation. So there is some really dramatic shifts going on in the plant and animal world that we absolutely need to be better at communicating. And so here are just a few examples of how I think you could advance that kind of information at your home institution. One is that you shouldn't be necessarily, if you're an organization that's a bit more hesitant to engage in these conversations, don't be. Just don't be. 72% on average of Americans agree with the statement that global warming is happening. In fact, there's now a majority of people in even states that you might not think about being well over 50% agreement with that statement alone. So start from there. You can share stories about how climate change is happening because global warming is something that the broad agreement of Americans is that it's happening. Where you can advance the conversation is the idea that you have personally experienced it. Find that local data about the shifting in the spring flower date, shifting in the onset of the springtime conditions, figuring out the papers that show and looking at the National Climate Assessment for data sets that tell a personal story about your particular area, because everyone has personally experienced the effects of global warming because of what I've just shared with you. Now, also what you're doing is encouraging people to discuss global warming. So as part of your programming at your institution, you can advance things like bulletin boards or idea boards or storyboards that are just simple, like write something down on a paper and post it and have people share stories about global warming, about their experiences with global climate change, because you might actually make and normalize a space for individuals who might not otherwise participate in it. And finally, engage with your local media about this. It turns out local journalists are always looking for local stories. So give that to them. Have them engage with you about the stories relevant to plants and animals in your area. Show them some data about the local flowering dates. Show them and participate in yearly estimates of when the last frost date's going to be. Engage with your local meteorologist. Talk about the planting of tomatoes. Encourage people to talk about these things, because then you can open the door for talking about global warming. I also encourage you to start hosting some sort of climate change symposia at your individual locations. There are almost always local universities or federal agencies that will come and talk about climate change. Like I said, 700 authors nationwide about the National Climate Assessment. Go search out your region's chapter and email the coordinating or chapter lead author. The Norfolk Botanical Garden put on several of these back in the day, and to really, really strong showing. Norfolk has the highest rate of sea level rise on the entire east coast of North America. They've done a lot to engage their community in things like composting and other sustainable practices, and that allows them to enter into these conversations very confidently. Now, also, you can be doing really interesting things for, like plant and animal habitat. I've done a few Eagle Scout projects building bee hotels. Now, you have to be really careful about the materials that you use and to upkeep them and things like that. But you can do this even on a small scale. You can do it with an individual, campaign around leaving the leaves. I don't know how many people I still see every year bagging their leaves and getting them out of their yard. Encouraging people to do more naturalistic landscaping like that can be one easy way that you promote biodiversity, which is changing considerably. Now, also, there are really cool citizen science projects that you can get involved in. Nature's Notebook and the National Phenology Network regularly publish and do kind of civic science around phenological changes. So they actually do these spring leaf index anomalies. Go to USNPN website to see those maps. It is really, really cool stuff that you can share on your social media and talk about this. And you can actually download an app that would allow you to do this really cool stuff. So this is like looking at the onset of shoot and leaf growth in 2 different types of plants. You can set up a youth program or an adult program, a master gardener program, that they would actually use their phones, an app on their phone, to actually then record when the leaf out is from year to year. And as you establish more than just like 1 year, even just looking at 2 years of data, you can have really interesting conversations about the differences between the weather conditions between year to year. And if you get over like 10 years from now, you have a really robust data set to start saying something about how the environment reflects in the plants that grow at your location. These are very, very interesting things to be doing, and it just requires entering into whatever space and lane fits your organization the most. Now, I will say that this is a responsibility of the informal learning world. We are one of the highest and most trusted sources of information. Botanical gardens, science museums, aquaria, zoos, we still hold the public's trust. We need to continue to lean into that by promoting these sorts of pro-environmental stories and working on exhibits and interactives that support that learning. So with that, thank you so much for your attention. Hoffman Science Associates, we also, would enjoy engaging with you about how to better do this at your institution. Feel free to reach out to me, jeremy@jeremyscotthoffman.com. Check out my personal website, and let's have a conversation about how that could work at your institution. So let's switch over to some questions, please.
Thank you so much, Jeremy. This was great. We had a lot of interest over here in the chat about talking about trees, and people were interested in the data that you were showing about allergens and oaks, especially.
Yeah.
And I guess I would summarize the question as have you seen interesting examples of adaptation around that issue?
Yeah, so there's a lot going on around home air purifiers. So one of the big things is that when you get home, to have some sort of air purifier, and you can actually do it very low cost. So a couple of like room fans with like air filters that you can buy at the store for like less than $30, you can make your own home air purifier. It's also really important that we just went through a time period where we all were wearing masks to keep ourselves safe. If you were especially afflicted during the spring, we're only a few months away, wearing masks outside, those KN95s, those N95s that you were wearing for COVID, those work really, really well to protect you from those really high allergy days. And then at the kind of like personal, that's at the kind of personal level. But unfortunately, these are really important biodiversity. They're really good for shading our urban neighborhoods. They're really good for sequestering carbon. So unfortunately, without choosing or promoting, deforestation, there's not really a lot that we can do other than taking those personal actions to reduce our exposure. And one thing, if you have pets, furry friends, make sure that they're being well groomed, maybe regular baths, during that season, because a lot of the pet dander and the pollen gets in their fur. And if they kind of get up in your personal space, you're going to be breathing that in more acutely.
Thank you. Thanks. And there's been a lot of great conversation in here too about just sharing resources. And so thank you for sharing those specific suggestions and resources that public gardens could maybe check out. I'm interested in the idea of sort of connecting to things that are personally important or personally familiar to people. And I'm curious about your thoughts about how do we as educators start to have those conversations with our audiences about like, what are those potential entry points or avenues for the things that they care about that we might be able to connect with?
Well, it tends that, we all care about a lot of the same things. We just don't tend to think that way. Food is one really easy way. Find a food that you really like. Tell people about how climate change is affecting that food and how you want to preserve that kind of food experience for future generations. you can think about the intergenerational perspective on this. People born today will be alive in 2100. I used to think 2100 was like this completely non-existent time in the future, but I know people now that are going to be alive when it's 2100, and that's wild to me. So thinking about and talking about the intergenerational kind of experiences and the relationship. A lot of our institutions, informal learning is done with a family setting, and intergenerational learning is part of what goes on at our institutions. So promoting that and having those conversations about like, here's what the world is going to look like, when our children are, our age. That's another really key way to do it. Talking about the charismatic micro and megafauna that we have. But one thing that this really does take is an internal look. So how do you relate your life experiences to climate change? I've told you that story about going fishing with my dad. That is a really important climate communication thing I did to you. So that's actually a tactic for connecting with people over shared experience, is to tell a personal story and to humanize your perspective on this big global issue and bring it home to your experience. So I not only told you a very meaningful and personal story, but that is one of the things you can use, storytelling about yourself, that will open up that conversation with others.
Thanks, Jeremy. I was also thinking about just the localizing of a lot of the stories that you told. And I was wondering if you wanted to say a word about some of the work that you've done on trees in some different cities. I know in DC and Richmond. I think this audience would be interested in that, and maybe where to look for a little more information about your work on urban heat islands.
Yeah. So one of the things that I've been really interested in for like the last decade has been how temperatures vary within human environments, like whether it's a big city or a small city or a town even. How does the lack of tree canopy in particular places, or the ubiquity of tree canopy in another, protect those places from heat waves or expose them to hotter heat waves? So this is known as the urban heat island effect. And almost without question, places in our cities that have very few trees can be several tens of degrees warmer during the most extreme heat events, including in Washington, D.C. We found a 15-degree Fahrenheit difference between the coolest and warmest place at the exact same moment. In Albuquerque, New Mexico, I think it was a 20-degree Fahrenheit difference between the coolest and warmest place. Boston, it was about the same amount. I saw the person talking about Boston. Wicked Hot Boston was the name of that program. You can Google the NOAA, NOAA, or NIHIS, NIHHIS, urban heat mapping campaigns to learn more about how temperatures might be varying in your community. And that's one really great way for our institutions to participate in local climate action, is by contributing to local climate organizations in doing tree planting or tree maintenance or plant maintenance. Showing up to these other organizations is another really key way that you can get involved. There's also a link on my personal website to share a little bit about our work in Richmond around that topic.
Awesome. Thank you. And you gave us some links, and Libby and I will share those in the chat so everyone has those. I want to end with one final question, because we're just lucky to have you as an expert on this. And I don't imagine you have the entire thing memorized, but when you think about the 5th National Climate Assessment, are there areas you would point us to as public gardens that we might want to check out and learn more and learn about sort of the updated thinking in some areas?
Yeah. So chapter 8, I think, is the ecosystems chapter. I think also, I think Libby just put in here a SoundCloud link to a neat podcast we did several years ago. I think the National Phenology Network is a great resource. And in the National Climate Assessment, the overview chapter is very, very powerful for like just talking about the findings of the general report. And then I think chapter 15 might be the health chapter, which is really related to those aeroallergens and mental and health or mental well-being is some way that gardens are a place that people go to relax and enjoy green space. So having that kind of like green space effect on our well-being is another really great way to enter into those conversations.
Great. Thank you so much. So thanks for that. And thanks for all the great resources that you suggested to us today. It's so helpful to have some new places to look to get some new ideas. Really appreciate you sharing all of your expertise with us today. And thanks to our audience who attended and asked all your great questions and had these great conversations. It's been wonderful.
Yeah, thanks so much for the invitation, and best of luck to everybody on their forays into climate science.
Thank you.